Energy, often in the form of electricity, is essential for all types of activities. The water treatment sector is no exception to the rule and has its own specific energy requirements. How is the share out of electricity in a wastewater treatment plant organized? To answer this question, we will first look at energy distribution in a facility, then take a closer look at high consumption items. It is interesting to analyze a wastewater treatment plant's electricity consumption. Water passes through the different treatment stages, which are generally pre-treatment, primary treatment, secondary treatment, also called biological treatment, and tertiary treatment. Here, we will look at a case that occurs very frequently, that of a regular wastewater treatment process, i.e., a site using activated sludge technology without being followed by a tertiary treatment process. At each of the stages, electricity is consumed so that the plant's various electrical and electromechanical equipment can function. We mainly find a lifting station to supply the plant with wastewater to be treated, scraping systems such as scraper bridges concentrate the sludge in primary and secondary settling tanks. The aeration system provides oxygen for the microorganisms as well as stirring during the biological treatment process. Two types exist: surface aerators and air-blowing systems. Agitators homogenize the effluent in the tanks and prevent deposits. A system with several pumps for extraction and sludge recirculation purposes. Sludge thickening and dewatering equipment. The odor removal system extracts, supplies and treats stale air from the different treatment areas. A group of low-energy consuming equipment such as reagent dosing pumps, valve actuators and instrumentation. Lastly, collective equipment such as lights, air conditioners or heating in buildings used for operators. Now, we are going to look more closely at equipment that consumes the most energy within these areas. In a conventional activated sludge treatment plant, the aeration system oxygenates biological tanks and accounts for a large portion of the energy consumed. The energy share of aeration usually accounts for 50 to 80% of the site's total electricity consumption. Various pumping posts represent one of the items that consume the most energy in the entire plant. Estimating energy consumption per equipment is calculated by multiplying the number of operating hours by its power input. In a wastewater treatment plant, different types of consumption can be found depending on the variability in operating time and the equipment's electrical characteristics. This information is generally provided under what is called the plant's power balance. Lastly, it is important to note that the distribution of consumption depends on the technology used and on the type of plant. Indeed, in plants using bacterial beds, the item that consumes the most energy linked to aeration is not present, thereby making the plant less energy intensive. So in regards to this technology, the energy distribution therefore varies greatly from one plant to another. What you need to remember: a wastewater treatment plant comprises different electrical and electromechanical equipment such as pumps, agitators or scrapers, sludge dewatering equipment or air treatment equipment that consume electricity. In a conventional activated sludge treatment plant, the system supplying oxygen to biological tanks is the item that consumes the most energy, accounting for 50 to 80% of the activated sludge plant's total electricity consumption.